Welcome to the course Business Analytics and Data Mining Modeling using R Part 2. So, in previous few lecture we started our discussion on our last module, that is time series forecasting. We also started discussing the first topic in this particular module, that is understanding time series. So, we have in previous few lectures we have been discussed a bit about time series. So, in the last in the last part of previous lecture we started our discussion on time series components. So, let us start from there itself. So, we talked about the time series components and typically we said as mentioned in this slide as well that this is probably the first step that one has to perform before we can move ahead and apply more formal techniques. So, identifying time series components is typically the first step before applying forecasting methods. So, as we discussed, there are 4 components for a time series. So, 3 components we have grouped together here, the label, trend and seasonality, because these are the 3 components which actually characterize the underlying series, and the remaining part is the noise. So, noise is the 4 component. So, then we started discussing each of these 4 components one by one. So, let us again discuss the first component, that is label. So, as we discussed in the previous lecture, label is average values of the series across periods. So, this gives us an indication about the whether on an average level, overall average level, how the values are being taken by the time series. So, that sense that indication we get from the level of the time series. If we look at the second component, trend, this is more important. So, this particular trend tells us about how the pattern how values are changing in series from one period to the next. So, pattern, so capturing the pattern of that change, how the values are changing from one period to next, that is defined as trend. So, as you can see in the slide, so trend is pattern of change in the series from one period to next. This is more important part of time series, and as we have discussed in previous lecture, 2 types of approaches where one is model driven, the another one is data driven. So, there if we are looking for if we are specifically focusing on trend component, how we should what kind of technique, what kind of methods we should be using for modeling. So, a lot of that is going to depend on this particular component, trend component. So, we will discuss this in more detail in this and coming lectures. The third component which is also very important is seasonality. So, what is seasonality? So, as you can see in the slide, that seasonality can be defined as a short term cyclical behavior observed several times in the given series. So, typically what swings that we see in a particular series. So, if those swings are short term, they keep on reoccurring in a short term manner, in a cyclical manner several times within the specified series, within the overall time period of the series that is there. So, that is defined as seasonality. So, seasonality is a short term cyclical behavior observed several times in the given series. So, trend and seasonality, these are the 2 most important components of a time series. So, whenever we are looking to model a time series for forecasting purposes, it is these 2 components, trend and seasonality, which we specifically focus on. So, this discussion will happen later in the coming lectures as well. The last component of time series is noise. So, as we have done in our previous course as well, the noise is defined in the similar fashion. So, noise here is also random variation due to unaccounted causes. So, anything that we cannot understand, it becomes part of the noise term. So, random variation due to unaccounted causes. We call it we define it as a random variation, because if there is any pattern if there is any structure left in the series, then we are supposed to capture that. So, whatever is left over, so that should not obviously have any trend or any structural form or anything. So, therefore, the remaining part should be the random variation part, which is why noise is defined in this fashion. So, noise is random variation due to unaccounted causes. So, always present in a series to some extent. So, there is always going to be some noise that is going to be associated or present in a series. So, these are 4 components. So, first one is label, the average values, the overall average values that are taken by the series. Then the second one is the trend, which tells about the change, rate of change, pattern of change in the series. And the third one is about the seasonality, if there are any cyclical behavior that is present in the series. Then the fourth one is the noise, the unaccounted part. So, let us move forward. So, once we understand that these are the 4 important components of a series, and specifically understanding or dissecting trend and seasonality components is more important for our modeling purposes, for forecasting purposes. So, how do we go ahead and identify these time components? There are various ways to do this. So, first we will look at some of the visual techniques, visual inspection that could be used to identify these components, and how these components, how whatever we have learned by applying these visual techniques, visual methods, how they can be incorporated in our formal modeling process. So, we will see that later. So, let us start with how some of these time series components can be inspected visually. So, the most important graphic, the technique, visualization technique that can be applied is time plot. So, we should create a time plot, and by examining the time plot of a particular series, we can look for, inspect for, manually observe what are the component and how they are there. So, first point is always going to be examining a time plot. So, what is a time plot? So, it is a line chart of series values over time with temporal labels on x axis. So, in previous course on business analytics and data mining modeling, so where we have had extensive discussion on visualization technique, we have also taken I think the same data set, the same example on bicycle ridership, and we have analyzed, looked at the time plots and other things, right. So, same thing, similar things we are going to repeat here in our discussion on time series forecasting as well. So, time plot is a line chart of series values over time with temporal labels on x axis. So, on x axis we have time index, and on y axis we have the series values. So, that line chart is essentially the time plot. So, this time plots we are supposed to dissect visually this time plot to understand nature of series components. So, we look to identify average level of the series. So, if once we have a look at the time plot, we will be able to see the visually also we will be able to identify which value on the y axis is typically in a way defining the level of the series. We can also see the shape of trend, whether it is linear or exponential or polynomial. So, that kind of thing we can also observe using the time plot of a series. Then cycle period of the seasonality. So, if there are any cyclical behavior that is present in the series, that should also be clearly visible in the time plot. We would be able to more often than not we would be able to identify the cycle period, and if there are and what are the peak period, what are the non-peak periods. So, in that sense, so some of these details we would be able to observe from time plot. So, what we are going to do now, we will discuss this example data set bicycle ridership. So, this particular data set data is on the ridership in the campus. So, this is about the bicycle ridership. So, the number of bicycles that are being used in the campus for traveling within the campus. so within or outside the campus. So that ridership, that data has been recorded on a monthly basis. So as you can see here, next point, series of monthly ridership. So for each month, number of riders that have been there, so that is recorded, and this particular series, number of riders per month, and based on that the series has been created. So we are going to analyze this series to find out the time series components. So before we go ahead and do that in our R environment, let us discuss a few more points about identifying these time series components. So one thing that we talked about is time plot. So visually inspecting, visually analyzing time plot can help us in identifying time series components. Other ways are also listed here. So we can examine time series visually by zooming in. So sometimes the period that is involved in a time series could be quite long. So in that sense, when we create a time plot, so the values can get mixed up, and if there are any for example, if there is any cyclical behavior shown by the series, that would not be clearly visible. So there are some components which would not be very clearly inspected using a time plot, just because the specified period is quite long. So zooming in is one way we can handle a long series. So as you can see, zooming in recommended for long series, so it can uncover hidden patterns. So typically when we talk about hidden patterns, it could be understanding the cyclical behavior and therefore the seasonality component of the time series. If we look at other ways, so the second one is also there, the changing scale of y axis. So as we talked about that on y axis we have the values related to time series variable. For example, the data set that we just discussed, bicycle ridership. So on y axis we are going to have the number of riders, and on x axis the time index is going to indicate the month 1, 2 and 3, 4 and so on. So that would essentially be Jan, Feb, March, so in that fashion. So for each of those calendar year months, what has been the ridership, what has been the number of riders in the campus, so that we can that we typically can observe in the time plot. Now changing a scale of y axis can help us understand the shape of trend. So as we talked about what is a trend, so a trend essentially we try to capture the pattern of change in the series from one period to next. So how changing a scale of y axis is going to help. So let us look at the other point. So typically scale of y axis is changed to logarithmic scale. So what would happen if we do that? So for example, if linear trend is visible, so if we create the if we change the y axis scale to logarithmic scale, then what is going to happen is, if there is any linear trend that is visible in the log scale, that would mean exponential trend in the original scale. So sometimes in the original scale, if the exponential trend is not quite clearly visible due to the nature of values taken by the series, so if we transform the scale on y axis, let us make it logarithmic scale, and if somewhat linear trend is visible, then that can give us the confirmation that the original series, in the original series the trend must have been near to exponential. So in that fashion, changing a scale of y axis can give us understanding about the trend, that pattern of change in the series from one period to next. Then let us move forward. The next thing that we can do to visually inspect the time series is adding trend lines. So which type of trend fits the series well? So we can add in the time plot itself. So we can add some of the trend line. For example, typically we expect the trends to be linear, exponential or cubic. So therefore we can add these trend lines on top of the time plot, and we can visually analyze whether those trend lines are fitting the time series values, are fitting the data or not. So that would also give us a sense in terms of the kind of trend that is there in the series. So, adding trend lines can help us in identifying the trend of the series. Let us move forward. So, there are a few more points which can also be used to find out to understand, to identify different time series components. So, the first one here in this particular slide is changing a scale of x axis. So, just like we talked about changing a scale of y axis and how if in the original series exponential trend is not cannot be clearly confirmed, and changing the scale of y axis to logarithmic, and if we see that close about linear trend. So, therefore, that confirmation can be done. Similarly, we can also change the scale of x axis. So, typically this is done so that to suppress seasonality. So, seasonality can be suppressed by changing a scale of x axis, and that would actually help us in understanding the trend component. So, suppressing seasonality to understand the trend if we change the scale of x axis. So, typically time scale for x axis is changed to a cruder one by aggregating data. So, as we have talked about in the previous lecture also, that when we are discussing the level component specifically, that if we aggregate data to a cursor level, then some of the sources of noise might cancel out, might average out. Therefore, the forecasting power of the series might increase and all that. So, that was the discussion. Similarly, if we change the scale of x axis, so essentially that would mean aggregating data. So, if we change this scale to a cruder one, then of course, some of the noises will cancel out, and typically when the noises cancel out, we are some of the cyclical behavior. So, as you might have seen before that if you create a plot for a shorter time period, you would essentially see some sort of cycles in those plots, in those time plots. However, if you take a longer horizon, so those values average out and you see a clear trend. So, we are essentially talking about that scenario. So, if we change the scale of x axis, for example, if we take the India's GDP numbers, and if we create a plot for GDP numbers for last decade from 2005 to 2015 or 2007 to 2017, that kind of series B plot, we would see ups and downs in the GDP numbers. However, if we take a plot for last 3 decades, and we would see a linear trend there, right, where the GDP has been continuously growing. So, once we change the scale of the series, once we increase the length, the sum of the things, some of these sources of noise cancel out. So, essentially that also suppresses the seasonality component of the series, and that would actually help us in understanding, in visualizing the trend component of the series. So, this is one thing that can be done. So, next point is about moving average plots. So, this particular point is actually does the same thing. So, if we create moving average plots, so that would also suppress seasonality and help us in understanding the trend component. So, this particular point is more related to what we are going to cover later in this module, that is about smoothing methods. So, the moving average plots, they are essentially part of that particular technique, smoothing methods. So, we will discuss more on this point in those lectures. So, what we are going to do is, till now we have discussed a number of points about how to identify time series components. So, we started with time plot and how time plot can be examined to find out different components of the series. We discussed this data set bicycle ridership, and then some other points which could be used, for example, zooming in, especially for a long series. Then the next point that we discussed is changing a scale of y axis. So, that would also help us in terms of understanding the trend of the series. Then the another thing, adding trend lines. So, that would also help us in understanding trend of the series. So, if we look at the points that we are discussing, we are mainly focusing on the trend component. So, trend component is the most important component in modeling series or forecasting a time series. Then few more points we discussed about changing scale of x axis and how that can suppress seasonality and help us in understanding the trend component. Similarly, moving average plots will also enable us in doing the same thing. So, what we will do is we will open RStudio and go through this data set that we talked about bicycle ridership and apply some of these points and try to identify the time series components. So, let us open RStudio. So, let us load this library XLSX. So, this is the data set bicycle ridership.xlsx. This is the file that we would like to import into our environment. So, let us run this code. So, this is the file. You would see that in the environment section the file has been loaded and we can see full DF is the data frame. We have 159 observations of 2 variables. Let us run this part of code also to eliminate any deleted columns. Now, we will have let us have a look at the first 6 values. So, you can see the first variable is month here, which is essentially capturing the time specific information. The second variable is the main variable, the time series variable, which is capturing the riders, the number of riders and for different months of a year. You can see in the first variable month here, we can see the only variation is in different rows is the month value is changing from 1, 2, 3, 4 onwards. So, these are first 6 observations and let us look at the structure of this particular time series data. So, now in this we can see data frame 159 observations, 2 variables, month here we can see it has been identified as a date date type of data structure in our environment. We can see this number of riders, we can see it is numerical. Now, to create before we can go ahead and analyze this time series and use it for modeling purpose, we need to create a time series object. So, for this we typically use this TS function. So, if you are interested in if you are interested in finding more about this particular function, so we can look at the help section TS. So, we can find out. So, we can see here time series objects, the function TS is used to create time series objects. More detail about this function and different arguments that could be used, you can find out from these usage and arguments detail. So, let us go back to our code. So, here we can see I am calling TS function and in the first argument itself I am using this data frame that I have full DF and the variable riders. Now, this time series variable, that is the number of riders that is going to be used to create this time series object. So, in the second argument I am also specifying the start and end time of the series. So, and then I am also specifying the frequency. So, as you would see if the frequency is being specified, then I typically do not need to specify the third argument, that is end of the series. However, we can do we can use all 3 functions, because these are the arguments that typically we would be using while creating these time series objects in RStudio environment. So, start of the series is this, we can see here 2004 January. So, that is the start and we have data up to 2017 March. So, let us create this object. So, we would see a time series vector has been created, you can see here in the environment section time series 1 to 59 and so these are the this time series object has been created using the function. Now, to create the time plot, we need to call this function plot. First argument is the time series object that we have just created, TSV, the time series vector. Then the labels, you can see right now year has been mentioned for x axis and riders has been mentioned for y axis. However, the label for x axis can also be changed to month year, because the data that we have in the series is monthly data. So, monthly ridership data that we have, and then LAS is also mentioned for the presentation purpose. So, let us create this plot. So, you can see the time plot for this particular series here, it has been created. So, you can see we have data starting from 2004 up to 2017, as we saw in the code, the end of the series. So, you can see how ridership of this particular time series has been changing month by month. So, we can see here how this has been changing. So, from this looking at this particular plot, this particular time plot itself, we should be able to identify few of the components of the time series. But before we go ahead and analyze this time plot, we can do certain transformation in the plot itself to reflect more detailed information. So, for example, we would like to change the labels on x axis. So, for that because if we want to specify the month as well, because this is monthly data. So, if we are interested in specifying the month on x axis labels, so we will have to use this particular piece of code. Here you can see first I am creating a sequence. So, you can see changing the command here, change x axis labels from year to month here. So, here first I need to create the sequence as dot date, and the starting date I have mentioned here, then the ending end date of the series I have mentioned also, and then by 2 years. So, because those are the tick marks that I might want here in the plot. So, by 2 years I would like to have this sequence and month name to be depicted on the plot. So, let us run this, we will have this sequence. Now, once this has been created, you can see at 1 this is a date object having 7 values here, as you can see. So, from that what we can do is we can format this particular date object and get the labels. So, from this date information we are interested in finding we are interested in extracting the information of month and year. So, in that sense, if you are interested in understanding this function a bit more, how we are doing it. So, at 1, as I said, the sequence 2004 11 to up to 2017 31 having 2 years interval has been created. So, more if you are interested in looking at these values, we can run this and you can look at the values of at 1. You can see 2004 11, 2006 11, 2008. So, this is the gap is 2 years, and we can see this particular sequence, 7 values are here. Now, we are going to format this because we want to create x axis labels. Now, we can look at the if we are interested in more detailed information on this particular function, we can look at here format. So, you will see that format this particular function, we can look at this particular function allows us understanding more about the understanding more about how we are going to use how we are going to format these labels. So, format dot date is the specific function that we might be interested in. So, you can see format x and other arguments. So, here we can find out different labels that could be used. So, here we will see that in this, let us go back to format. So, we are I just want to show you this these formatting option that I have picked here, I have picked from this function. So, I think the details would be here down in this particular function. So, you can find out the detail of these formats. So, what these different formats represent actually. So, in this we will see that either in the format or on the format dot date you would see that these percentage B and percentage Y. So, B is representing month and the capital Y this is representing year, and in exactly what format we can also see that from the output. So, what I will do, I will run this particular part of code and we will see this. So, labels I have just created this particular variable, you can see this is a character vector and you can see in this format we will get. So, a smaller b that actually represented the month in this form, and then we had y which represented year. So, now we have the labels in month and year format. Now, we can use this. Now, to identify the tick marks also. So, if we go back to the plotting, so we need to identify these tick marks where the labelings are to be plotted and the labels name. So, what we have just created in the labels 1, we have created the labels for us. Now, we also need to compute these tick marks where these labels are to be plotted. So, add to will actually allow us that. Let us run this. Now, we will stop at this point and we will continue our discussion on time series forecasting and specifically this part of the code where we are looking to analyze time series components in our studio environment in the next section. Thank you.